Hi everyone, welcome to a review of the examples from Geometry Lesson 2-1 using inductive reasoning. In the first example, we're asked to find the next item in each pattern. In the first pattern, they gave us Monday, Wednesday, Friday. Notice they skipped Tuesday, they skipped Thursday. That means I should skip Saturday and write down Sunday. Okay. In the next pattern, we have 3, 6, 9, 12, 15. Notice they're adding 3 each time. So all I have to do is add 3 to 15 to get 18. Another thing I could recognize is that this is 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. So I need 3 times 6, which is 18. Next, they gave me a pattern like this with these arrows. It's pointing to the top left, to the top right. So I need to make it point to the right. And that would be the arrow I need because it's slowly rotating in this direction. Okay, next in example 2, they asked us to complete a conjecture. So we need to figure out what the pattern is or what's true about all these things. So it says the product of an even number and an odd number is, so I need to pick even numbers and odd numbers and see what I get. So 2 times 3 is 6. 4 times 1 is 4. I can do 6 times 5 is 30. Notice all these results are even numbers. So that's an even number there. And that's my answer, even. In part B, they asked us to complete the statement that the number of segments formed by n collinear points is, so I'm going to see if I can find a pattern. I'm going to make a table, and I'm going to give myself enough room to do a diagram in the middle. N is going to tell me how many points, and over here, I'm going to find the total number of segments. So if I have 2 collinear points like this, there's only 1 segment that's made. If I have 3 collinear points, I'll have the 2 short segments and then the total segment. That's 3 segments. If I have 4 collinear points, I'll have 1, 2, 3 short segments, this long segment, and then this long segment. So that's 2 segments that are 2 parts long, this one and that one. And then I have the total segment again. And this adds to 6. If I had 5 segments, which I'm going to do, I ran out of room, I'm sorry. I'm going to do it up here. 5 segments, I'll have 1, 2, 3, 4, 5. Okay, so I have 1, 2, 3, 4 plus the ones that are 2 parts long. So 1, 2, 3. And then the ones that are 3 parts long. So 1, 2, 3. That's this segment here. That's 1. And then from B all the way down to E, that's 2. And then I have the total segment again. So that is 10. Notice what they're doing with these numbers. Here we have just 1, and then we have 1 plus 2. Then we have 1 plus 2 plus 3. Then we have 1 plus 2 plus 3 plus 4. And notice that this biggest number over here is always 1 less than the number over here in the n column. Okay, so this was a 3, it's 1 less than 4. The biggest number that I added here was 1 less than this. So I can say is the sum, which means adding, the sum of the numbers, or whole numbers if you prefer, which makes a little more sense, the whole numbers. Let me just write the word whole here. Okay, less than n. okay? So it's the sum of the whole numbers less than n, because if n is 5, I have to add up 4, 3, 2, 1. If n was 6, it would be 5, 4, 3, 2, 1. If n is 7, it would be 6, 5, 4, 3, 2, 1. So it's all the whole numbers less than the number that I'm given of collinear points. Okay, we have one last example. It says, show that each conjecture is false by finding a counterexample. Now, a counterexample is a specific example that something is not true. So you just need one number or one picture or one thing that shows that it's not true. Don't make a statement that says, well, this just isn't true for all numbers. Now, when they give you equations like this, it's best to try 0, negative numbers, fractions and decimals. Usually you will find something, and 1 usually works as well. So usually one of these, if they're allowed by the conditions of the question, will provide the counterexample. Okay, so notice in part A, they limit us to positive numbers. So negative numbers are out. 0 is neither positive nor negative, so that one's out. So we're down to fractions or 1. So if I put in a 1, I get 1 over 1 is less than or equal to 1. So I just made all of my n's 1. And notice that this is still true because 1 is equal to 1. So that's still true. This is not a counterexample. So let's try a fraction. Maybe n is 1/2. And I can do 1 over 1/2 is less than or equal to 1. And let's see if that works. 1 divided by 1/2. You flip the fraction and change to multiplying. So you get 2. So this says 2 is less than or equal to 1. That is not true. This is my counterexample. If n is 1/2, it's going to make this inequality not true. Okay, so that's the one I needed. Now, sometimes they'll give you a geometry example like this one. It says, for any 3 points in a plane, there are 3 different lines that contain them. Now, it's important to figure out what in the world they're talking about before you start trying to figure out what the counterexample is. So I have a plane, and I have 3 points in the plane, and I need to connect them. Okay, so connecting them with lines, 3 different lines to connect them. Okay, so there are 3 different lines that have to connect these. If I try and connect them any other way, I'm still going to get this crazy looking triangle here. Okay, it's always going to be shaped like a triangle. So I need to figure out how to move these points so that they don't make a triangle shape. So one way I could do that is by making them collinear, meaning they're on the same line. So that way there's only one line that contains all 3 points. So there aren't 3 different lines. This is my counterexample. Now, my final part of this example is down here. Sometimes they just ask you to look at data that's given to you and find the counterexample. So this says the temperature in Abilene, Texas never exceeds 100 degrees Fahrenheit during the spring months, March, April, and May. So these are the spring months right here. So I need a counterexample, and this one is it right here. In May, the maximum temperature was 107, which is more than 100. So that's the counterexample. May was 107. Okay, that's it for this lesson. Let me know if you have any questions.